70. Longest ideal subsequence. So for this problem, we are giving a string S. So inside of the S, it's gonna be just lowercase English letters from A to Z, and we are also giving an integer k. So we call string T ideal if the following conditions are satisfied. So T is just a subsequence. So first of all, T is a subsequence of S, and secondly, the absolute difference in the alphabet order of every two adjacent letters in T is less than or equal to k. So first of all, it meets the subsequence, and secondly, it must meet the distance less than or equal to k. And we're going to return the length of the longest ideal string. If we read from here, it seems that this problem is similar to longest increasing subsequence. So this is the meaning of the subsequence, and we should also note that the alphabet order is not cyclic. So this means the absolute difference in the alphabet order of A and Z is 25, not 1, and we should be careful about that. Yeah. So in the first example, we're gonna choose a string ACBD because it meets the first condition and the second condition. So the first condition is it is a subsequence, and the second condition is the absolute distance is less than or equal to k, equal to 2. Yeah. If we read it from here, we should know that if the length of the string is 10 to the power 5 and there are only 26 English letters, so this means it may be the time complexity is going to be the length of the string is n and this is k. Maybe the time complexity is nk. Maybe we're going to use a dynamic programming to solve the problem. Yeah. So we're going to define an F array. So this F array means if currently if we are adding with these characters, maybe C, maybe yeah. Let me just use another letter. If we are adding, so this is going to be starting from A, B, C, and D until to Z. So this is our definition. So this means if we are adding with this character B, what is going to be the longest subsequence that meets the condition 1 and condition 2. If we are adding with D, what is going to be the longest result? So this is the idea. So let me just use the first example to explain a little bit. So from the beginning, we're going to set all those values to be 0. So this is our definition. Yeah, because from the beginning, we didn't use any characters yet. So we're going to think, if we are adding with A, B, C, D, or other letters, it's going to be, the longest length is going to be 0. Now we're going to check the letters one by one. So first of all, we're going to check this character A. So for this character A, we're going to check the distance because the distance is 2. But this is the first character. It means from index 0 to index 2, because 0 plus 2 is going to be 2. So from index 0 to 2, what's going to be the maximum number? 0, 0, 0. It is 0. So we're going to use the maximum number plus 1 because we're going to use this character A. So now we're going to update this character A from here to 1. So this means if we are adding with the current character A, the longest length is going to be 1. Now we're going to check the next one. It is C. So for this C, we're going to check from the left side to the right side. We're going to check the maximum number for distance of 2. So the maximum value is 1 because for here it is still 0. So for example, if this is E, this is F, and this is G, it is still 0, right? And this is others. Now we're going to choose this C. From the left and from the right side, it's going to have a distance of 2, and the maximum number from A to E, it is 1. So it's going to be 1 plus 1. So it means if we are adding with C, the longest subsequence is going to be 2. So now we're going to update this value from 0 to 2. Now we're going to check the next one. It is F. So for this character F, we're going to check the distance from the left side to the right side. It is always 0. So this means from here, we're going to update this F to 1. Yeah, if we are adding with F, so the longest subsequence is going to be 1. Now we're going to check this character G. So similarly for this G, we're going to update it to 2 because the maximum value is going to be 1 plus 1 is going to be 2. Now we're going to check the next B. So for this character B, we're going to check the left and to the right side. So the maximum number is 2. So we're going to update this character B. So it's going to be 3. Now we're going to check the next one. It is D. So for this character D, from the left side, we're going to check from here. What's going to be the maximum number? It is 3. So 3 plus 1, it's going to become 4. So what's going to be the final result? The final result is going to be the maximum of this F array. Because we need to check all the possible cases. If we are adding with A, adding with B, or adding with Z, all those cases could be a possible answer. So we're going to return the maximum of the F array. So this is exactly like a dynamic programming, and it is similar to the longest subsequence problem. Yeah. Now let's try to solve it. So for the F, we're going to define it as 0 times 26, because there are only 26 characters for lowercase English letters. Now we're going to check the characters 1 by 1. So for C inside S, I'm going to use an index I, because I need to check the index. Actually, the index is for this character. So we're going to use, in Python, we're going to use odd. So minus the odd A. So this is the index. Now we can update it according to dynamic programming. So Fi, as I said before, it's going to be the maximum value of something plus 1. And finally, we're going to return the maximum of F array. So inside of F, we're going to check the distance. So it's going to be I minus K to I plus K plus 1, because this is a Python, we need to plus 1. So for I minus K, because it can be a negative value, but we cannot have a negative value for the array. At least we need to have a 0, so we're going to choose a maximum of 0 to I minus K. Now I'm going to run it to check the final result. Let's see. So the indices must be integers or slices, not tuple. I did something wrong. Let me check it. Yeah, from here I cannot make it a tuple. I need to use the slices. Yeah, now let me just run it. As you can see, now it works. Now let me just submit it. As you can see, it works and it's pretty fast. Now let's analyze a little bit about the time complexity. So for the time complexity here, this is the length of the string. This is the n. And from here, we're going to check a maximum value. So the maximum value going to be the maximum length of the array. It's going to be 26. So the time complexity going to be n times k. And the space complexity going to be 26. I think that's all about it. Thanks for watching. See you next time.